Alright, so here's another empirical formula problem, and we're looking at these percentages: hydrogen, manganese and oxygen. What we're going to assume is that we have 100 grams of compound, which means that each of these percentages then represents the number of grams. So 100 grams of compound, there'd be 0.830 grams of hydrogen, 45.8 grams of manganese, 53.4 grams of oxygen. So the first thing we do is we want to figure out the number of moles of each of these. So the number of moles for hydrogen first would be 0.830 grams times, well, it's hydrogen. Well, grams of hydrogen will be on the bottom. To cancel out, moles of hydrogen be on top. 1 mole, 1.01 grams of hydrogen, so we're going to end up there with a 0.823 moles of hydrogen. And then we'll have the moles of manganese, and that's going to be 45.8 grams of manganese. 5 grams of Mn on the bottom. We'll have moles of Mn on top. 1 mole of manganese, and we've got 54.94 grams. Again, the atomic mass of manganese. That comes out to be 0.834 moles. So already you can see that this relationship is going to be pretty close to 1:1. That's manganese there. And then we'll do the moles of oxygen, and that's going to be 53.4 grams of O times, and we'll have grams of oxygen down here, moles of oxygen on top. Again, we're dealing with atomic oxygen, so it's 1 mole is 16.00 grams of O. We're not dealing with molecular oxygen, O2. And that's going to come out to be 3.33 or 3.34 moles of oxygen. Now the next thing we want to do is we want to take each of these and divide through by the smallest one. So we can see that 0.823 moles, this is for hydrogen, divided by 0.823 moles. And that's going to be 1, and that's for the hydrogen. We're going to do the same thing for the manganese now. It'll be 0.834 moles divided by 0.823 moles. And that's going to be that'll be 0.988, which for all intents and purposes is going to end up being rounded to 1 anyway. And then we've got the 3.34 moles of oxygen divided by 0.823 moles. And that's going to pan out to be 4.06. And that's going to end up rounding to 4 as well. So you can see that this would be for the manganese, and this is for the oxygen. So you can see that what's going to happen is that we're going to end up getting a ratio of H is to Mn is to O will be 1 is to 1 is to 4. And since these are very close to whole numbers, the multiplier in each instance will just be 1, which will end up giving us our empirical formula of HMnO4.